All right, so in this question, we've got a couple of different things going on. So driving 90 miles at a constant rate. In this setup here, we're going to have to, since we're talking about distance, rate, and time, we're going to use what I call the DIRT formula, the distance equals rate times time. Okay. So it says that you're going to, on a recent road trip, you're going to drive 90 miles at a constant rate. So I'm going to call this the original trip. Okay, so the original trip here, we're looking at 90 miles. Okay, so 90 miles equals to, okay, we don't know how long it's going to take, or how long it took, or we don't know the rate either, so rate and time. Okay. On the, we're saying that if you would have driven 15 miles an hour faster, your time would have been reduced by 0.5 hours. What was your original rate? So I'll call this the proposed trip. Okay, so we're still doing 90 miles. Okay, but here we're saying that the rate is going to be 15 miles an hour faster, and that's than the original one. So it'd be r plus 15. Okay, and then the time is going to be reduced by 0.5. So reduce, so subtraction 0.5. Okay, so now I have the setup. Now remember, if you have two variables, you need two equations, which we do have now. Okay, so we're going to go through and solve it. And it says we want to find what the original rate is going to be. Okay, so in this case here, I'm going to take, it doesn't matter which equation you use, but I'm going to take this equation on the left here and solve it for r so that I can plug it into the other equation. So here I get r is equal to 90 over t. Okay, so I'm going to take that and plug it in for r right here. So I get 90 equals to 90 over t plus 15 times t minus 0.5. Okay, so now I have this set up. Okay, so it's up to you how you want to deal with this thing, but really we need to FOIL out that right-hand side to actually get at what's actually being done for the left-hand side to move that over so we can use the zero product property here. So here I'm going to have 90 equals to, when I FOIL this thing out, 90 over t times t, the t's would cancel, I'm just left with 90. Okay. When I multiply negative 0.5 times 90 over t, I end up with minus 45 over t, okay? And then I get 15t, and then the last one I'm going to get minus 7.5, okay? So that's half of 15, negative times that 15. So in this case, what's nice, the 90s just cancel out. Okay, so now I'm going to be left with 0 equals to negative 45 over t plus 15t minus 7.5. Now, this is kind of hard to solve because it's not a quadratic at this point. So what's going to throw things off is the fact that there's this t in the denominator and there's a t over here. If there only one of them, this would be an easier problem. So to get it so we're back into familiar territory, if I multiply through by t, I end up with 0 equals to negative 45 plus 15t squared minus 7.5t. Okay, and then at this point, it's up to you how you want to go about solving this question. If you go through and, you could go through and get rid of your coefficients by dividing through by 7.5. That'll also work. 7.5. Oh, let's go ahead and write in descending power of x. So we have 15t squared minus 7.5t minus 45. Okay, but it's up to you how you want to go about solving this thing from here. For me, I'm going to go ahead and deal with the with solving this thing in terms of let's see. I would go ahead and I would divide through by 7.5. So 45 divided by 7.5 is going to give us 6. So we'll end up with 0 equals to, so 7.5 goes into this 2 times, so 2t squared minus just t, and then minus 6. Okay. Now it's up to you how you want to go about solving this thing, but use quadratic formula or however you want to go ahead and do that. Okay. All right. And then solutions are all done, so I'll let you finish that last part. Okay. Hope this helped.